Numbers and counting are an integral part of human life. In our day-to-day life, we are using modern machines to help us solve the counting problems. These modern machines speed through some tiresome jobs. Here is a machine that can add, subtract, multiply, divide and do many other things. Long back before the discovery of these intelligent machines, numbers and counting were still a part of daily routine. And to do the same, man used the available resources. These were sometimes inbuilt, like fingers, and sometimes external tools, like counters, notches and sticks, knots in a rope or pebbles. Like for counting the total number of sheep in his flock, each pebble represented one sheep, helping him to tell how many. This system worked well for a while for smaller calculations. But gradually his flock grew larger and larger. And with progress, he began to own so many other things that using one pebble for each object became way too clumsy. Man realized that something quicker and easier is needed to show how many. What do you think man did to solve this problem? Well, he thought and took out a simplified solution. He decided to put the counters in the similar way as we write numbers on papers, taking 10 counters out of the original line of counters and then placing one counter in a line at the left to stand for 10 ones. This idea led him to make one of the first counting machines, which we call an abacus. The abacus was invented thousands of years ago, but it's still used today in many parts of the world. The history of abacus dates back to 2700 BC, when the first precursor of modern abacus, the Sumerian abacus, was used in Mesopotamia. This primitive device was used for doing addition and subtraction. However, it proved difficult to operate and perform higher calculations. In 300 BC, the Greeks discovered Salamis tablets, which was used by Babylonians. It was made of marbles and had sets of parallel lines drawn into it. This device was used for doing calculations which cannot be done mentally. The Roman hand abacus was invented in 500 AD. It was created to be portable and convenient for merchants and travelers. After these primitive precursors, the first most useful and technically correct abacus was invented by the Chinese, called as the Suan Pan, meaning the counting tray. Traditional Chinese says that the abacus or Suan Pan was inspired by hunters collecting trophies from the animals they killed. People started to string wooden beads or wooden sticks to keep track of the count, which ultimately gave rise to the idea of the abacus. The Suan Pan is typically 8 inches tall and with various widths depending upon the number of rods. Usually it has 7 to 17 rods, having 2 beads on each rods in the upper deck and 5 beads on each rod in the lower deck for both decimal and hexadecimal calculations. The Suan Pan abacus is still used in China for doing arithmetic calculations, and the speed of calculation on the abacus can easily beat modern-day calculators. During the 14th century, the Chinese Suan Pan abacus was introduced to Japan, where a famous mathematician, Shikikowa, simplified the Chinese Suan Pan by removing 1 beads each from the upper and lower decks, and resulting in the modern-day abacus, called the Soroban abacus. Although the idea of abacus is very old, it is used for us as modern as satellites, space travels and guided missile. By understanding and using the abacus, we can discover the meaning of our decimal number system, to understand the modus operandi of abacus, and how counting can be done on the same. These children are doing some calculations on open-end abaci. These are boards on which we have fitted sticks to show grouping of ones, grouping of tens, grouping of hundreds, groupings of thousands. We put counters on the sticks to show how many of each grouping we have. When we add 8 and 4 on our abacus, we put 8 counters on the sticks, and then we put on 4 more and we have 12 counters. But here's a thumb rule of abacus. Just as we write numbers, the largest value we show in one position cannot be more than 9. When we have 10 or more counters on any stick, we take 10 counters off and use 1 counter to stand for a group of 10 on the adjacent stick. The adjacent stick can be of tens place or hundreds place or so on. So we take 10 counters off the one stick and use one of the 10 counters to place on a 10 stick. The 1 counter on the 10 stick stands for one group of 10. We have 1 10 and 2 1s or 12. Can you add 26 and 16 on your abacus? We show 26 on the abacus as 2 10s and 6 1s. Now we add 6 1s to the 1s position. This makes 12 1s. So again we take the extra 10 counters off the 1 stick and in place of them, we add 1 counter worth 10 to the 10s place. Thus we have 4 10s and 2 1s, and we can read the answer on the abacus 42. If we add 43 and 72, it works like this. 3 1s and 2 1s make 5 1. 4 10s and 7 10s make 11 10. What do we do if we have 10 or more counters on the 10s place stick? We take 10 counters off the 10 stick and group them as 100 on the 100 stick. The abacus shows 115 as our answer. Let's see how we show 0 on our abacus. We add 5 1s and 5 1s, and we have 10 1s. And when we take 10 counters of the 1 stick and put 1 counter on the 10s place stick, to show a group of 1 10 there aren't any counter on 1 stick. When we write 5 plus 5 equals 10, we use a 0 to show not any 1s. Do we need a 0 on the abacus? Well, let's see on the abacus. We don't need a special counter or marker for a 0, and the stick that hasn't got any counters or is empty is showing the value as 0. Do you see why we talk about carrying in addition? When we group 10 1s and 1 10, we say we carry 1. We mean that we group the 10 1s to 1 10. When we group the 10 10s to 100, we carry 100. The one we carry always stands for a group of 10 of the value to its right. Subtraction works in the opposite direction from addition. When we add, we increase. When we subtract, we decrease. There are 2 directions for counting increase and decrease. Let's work this example. To work the example, we can show 35 on the abacus, 3 10s and 5 1s. Then we can subtract the 1s. 5 1s minus 2 1s leaves 3 1s. Next we subtract the 10s. 3 10s minus 1 10s leaves 2 10s. The answer is 23. What about 42 minus 16? We will show 42 on the abacus. We want to take away 6 1s, but since 6 1s are more than 2 1s, we must use one of the 4 10s leaving 3 10s. We regroup the 1 10 to 10 1s, adding them to the 2 1s, making 12 1s. We subtract 6 1s from 12 1s, leaving 6 1s. 3 10s minus 1 10 leaves 2 10s. Our answer is 26. 1 counter on the 100 stick stands for 10 counters on the 10 sticks. Do you see that each time we move a counter one place to the left, it stands for a value that is 10 times as large as it was before? If we move the counter 2 places to the left, it stands for a number value that is 100 times as large as it was before. 3 counters on 10 sticks stand for a value that is 10 times as much as 3 counters on the stick. The 3 counters on the 1 stick have a value 10 too small as the 3 counters on the 10 stick. As man needed to show larger and larger numbers, he could keep adding more sticks to his abacus, as in writing numbers we can keep on and there is no last number. The idea that worked with ones, tens, hundreds and thousands can go to tens of thousands, hundreds of thousands, millions, tens of millions, hundreds of millions, billions, and on and on and on. After have gone through the details, let us recollect what we learned about abacus. Positions on abacus are like positions that we use when we write numbers: ones, tens, hundreds, thousands, and so on. The largest number value we write in a position is 9. Similarly, on the abacus, we show only 9 counters on one stick. When we add numbers like 8 and 8, we have 16 counters on the stick, but we group them as 1, 10, and 6 ones. When we subtract, we can regroup 1 10 to 10 ones, 100 to 10 tens, and so on. The stick that doesn't have any counters on it acts as placeholder. It serves like 0 we use when we write numbers. The idea of grouping and regrouping are great ideas. The number system is one of the greatest things that men ever invented. The abacus can help you understand the number system. Abacus was a wonderful invention of its era, but in the modern time, with the presence of high-tech calculating machines, abacus has found its use as a complete brain development tool for children between the age group 4 to 15 years. Small children across the globe are showing magical results by using a program called Mastermind Abacus.